started. Okay, recording in progress. So hello and welcome to the monthly Applied AI Meetup. For those of you who don't know, that we meet virtually every month on the first Thursday of the month, and we do already have a full lineup of guests through the end of the year. So please be sure to visit our Meetup page and sign up for the upcoming sessions if you haven't done so already. For those of you that live in the Minneapolis-St. Paul metro area, we are thrilled to welcome you to join us at our first Applied AI conference. This will be a one-day event on Friday, November 4th. It will be in person at the North Star Scouting Space at Base Camp in St. Paul. So space is limited. Here's the important part. Sign up tonight because early bird pricing ends tomorrow. This is your last chance for early bird pricing. Tonight at our meetup, we are excited to have you joining us to learn how to get business value from your AI models. We're joined by my friend and colleague, Fraser Gray-Smith. He is a fellow senior consultant at Slalom Consulting. He is a problem solver, a self-professed geek, a lifelong learner, and an awesome guy, I might be biased, who has spent the last 8 years building and leading analytics teams across a wide array of industries. His focus is on teaching organizations how to implement AI in ways that drive business value. Take it away, Fraser.
All right, so I'm going to share my screen here, and then we can kind of get started. There we go. Okay, so let me make sure that that's the. Can you see the screen there?
Yes.
Yep. Okay, perfect. So this is
your screen just disappeared.
No, it should be there.
Now it's back.
Okay, perfect. So I put together a couple of slides because I'm a consultant, and that is sometimes what consultants do. But I promise this is not going to be death by PowerPoint. This is meant to be a very interactive session. I'm going to talk for a little bit. Please feel free to interrupt me if you agree or disagree or have a question or want to tell me that I'm wrong. I'm always open for feedback, so please feel free to tell me any of those things. I do love to hear it. I'm going to be talking about, as Allison mentioned off the bat, how to get business value from our your AI models. So a quick introduction to myself. Who am I, and why should you listen to me? Here, if it gives me any kind of credibility with this group, I'm a consultant for Slalom Consulting. I specialize in AI, machine learning, and analytics. I have a bachelor's degree in finance administration, a master's degree in international business, and I'm almost done my second master's degree in computer science. So if that buys me any credibility with this group, fantastic. If it does not, my apologies. And I've spent the last 8 years working in technology or tech adjacent roles across a number of different industries. So a quick story. I actually got into AI by accident. And I like to say that because it feels very true to my own story. I actually started out in finance. As you can see, I studied finance as my bachelor's, and I thought I wanted to be an accountant. I did an intern, between my third and my fourth year of university, and after my fourth year of university, I did a couple of internships in accounting at a few different banks, and I discovered very quickly I did not want to be an accountant anymore. So I did what all good bankers do, because I was working for a bank. I went into financial restructuring, which is a very, very nice euphemism for saying I worked as a consultant that fired a lot of people. And I decided I did that for a hot minute, and I decided I really didn't like that either. However, that experience was really, really valuable for me because it taught me two things. Number one, I was pretty good with numbers. And number two, I understood how businesses made decisions and understood how businesses thought about, what is valuable and how to actually get value. So while I didn't like the job, I learned a lot from it, and it really informed the rest of my career. So After doing that for a little bit, I went to work for a telecommunications company here in Canada. As Allison mentioned, I am Toronto based, so I'm north of the border. And there was this role that came up. It was called a strategy and analytics specialist. And so I met with the hiring manager. I was fortunate enough to kind of get an interview, and I said, "Hey, I think I can do this strategy side. I've been a consultant for a little bit. I've got a background in finance and a master's in international business, and I'm really enthusiastic about the analytics side." And thankfully enough, they took a chance on me, and I was able to learn kind of the analytics side. It started out very, very simply, with an SQL textbook every night, highlighting code and then taking it to work the next day to try and figure out how to use it. I had discovered I loved it, and I've been doing technology. I moved deeper and deeper into analytics and technology roles and haven't looked back since. The reason I tell that story is because that kind of dual background gives me a bit of a unique perspective. Because I've done the work in technology, and because I started out really in business, that gives me a lens that someone, if who just studied business, you may not understand the technology side. And if you just came from an engineering or a science background, you may not understand the business side. So that kind of gives me a unique perspective. Or as both my business friends and my engineering friends like to tell me, I'm equally bad at both. So that's a quick introduction to who I am. Every good deck needs a table of contents. We're going to talk about why you should care about this problem. I'm going to tell a couple of hopefully funny stories. We've got a couple of case studies explaining different ways in which organizations trip up or make mistakes when they're implementing their AI initiatives, and then how to correct for that. And then I'll leave you with some parting words. So without any further ado, why should you care? And this was this was in the introduction to the meetup. So if you've seen the introduction to the meetup, this may seem familiar, but there's two numbers I really kind of default back to when I'm talking about AI. The first is $13 trillion. This is the global economic impact of AI by 2030. That's 13 trillion US dollars. That is a monumental amount of money. That is more money than most countries' entire GDP. That is enough money to justify every AI project, every organization having at least some usage of AI. The second number, and the reason I like these two together, is the kind of contradictory one, which is 85% of all AI projects fail. And the reason I like there's a number of, when we talk about that failure rate, we're talking about 85% fail to produce business value. And even digging even deeper into that, only 53% of AI projects even transition from prototype into production. So 53% of, or 47% of projects never make it past the prototyping phase. And I think these are problems that you can address them if you understand the typical tripping places where you can trip up. So the question I like to ask is, how can both of these things be true? How can AI have such a high failure rate and also have such a high economic impact, or high projected economic impact? And the reason that both of these things can be true is because a lot of organizations are launching every possible AI project they can at it. I recently saw an advertisement, and I get I yell at the TV every time I see it, and my wife makes fun of me. Home Depot has an advertisement, at least in Canada, where they're advertising that their washing machines are powered by AI. I'm not sure we need AI in our washing machines. I'm going to say it right now, and maybe that's a taboo thing to say in front of a number of AI experts. I'm not sure we need AI in our washing machines. But the point here is that companies are throwing everything they possibly can at AI, knowing that that even if one or two of their initiatives succeed, that they'll be able to see huge value. So wouldn't it be amazing if, instead of having an 85% failure rate, even if you brought that down to 50%, think of how much more value you could achieve as an organization. Think of how far ahead of the curve you would be than your competition. So that's really the crux of the talk today. There's going to be 3 use cases that I'll walk through on AI and the things that companies tend to get wrong. Obviously, some of these case studies will be anonymous. The first one is not, and you may have heard of this company before. There was a company in Canada. It was founded in Montreal. It was called Element AI. And I want to tell you a little story about them because they're a really interesting use case. So Element AI was founded in Montreal. It was founded as a consultancy to using AI to solve business problems. I actually had a number of friends who ended up working for Element AI. They're very, very well known. If you want to look them up, there is a very well-known professor from Université de Montréal, University of Montreal, that partnered with Element AI and lent his kind of credibility. He was really one of the founding researchers behind neural networks. So he was, it had very, very strong bona fides, very, very, it was very well backed, and it was supposed to be, this giant consultancy that was growing up. So October 2016, in January 2017, so only about 3 months later, they raised $102 million from Series A investors. So they did this is not a small venture at all. This was they're going right for it. They're gonna make, this is gonna be on the scale of, in the billions of dollars very, very quickly. So 2018 rolled around, and I put 2018 because this kind of happened over the course of 2018. Element AI claimed their first couple of clients, and you might start to see where the warning signs start to pop up here. Their first couple of clients were Bank of Montreal, Amnesty International, and the Port of Montreal. Bank of Canada, Amnesty International, and the Port of Montreal. So a very wide group of clients here. There's a number of them. There were others that were unpublished at this point, but those were the first kind of big ones that they were willing to speak about. And then in April of 2019, Element AI started to do a bit of a pivot. They said, okay, well, this consultancy thing, it's interesting, but we're going to pivot, and instead we're going to release a product. And we're going to release a product for AI-assisted insurance underwriting. So didn't really have anything to do with their clients before, but now they're going to pivot and they're going to do something different. And in order to support that pivot, a number of months later, about 5 months later, they raised an additional $151 million. Now, at this point, the terms of the deal were never publicly disclosed, and they still haven't been, but it's estimated they had about between a $600 and a $700 million valuation. So this is a serious company. This is a fairly large company. And a number of investors into the company, were McKinsey Consulting, Microsoft, NVIDIA, and Intel. So these are serious investors. They're people who know their stuff in this industry. A couple of months later, it happened sometime towards the end of 2019. They released some new software to help manufacturing companies manage data sets. So thus far, we've had some banking clients, an insurance underwriting product, and then products for manufacturers to help them manage data sets. And this is where throughout this, you can start to see the thread of trouble. And then finally, or most recently in November of 2020, they ended up being purchased by ServiceNow for $230 million, the whole company. So in the span of between September 2019 and November 2020, they went from about a $600 million valuation to a $200 million valuation. They lost about 66% of their value. Now, Element AI sort of still exists within ServiceNow, but really the reason that ServiceNow acquired Element AI was because they were really interested in the engineers that worked for them. They weren't interested in the product or the company or the clients. And this is the key theme here that I want to point out, and I've alluded to it a couple of times. They went from working with the Bank of Canada, which is requires very specific domain expertise, requires deep subject matter expertise in order to apply AI in an intelligent way. And then they switched gears and then they did insurance underwriting, which also is a very niche industry, requires very specific subject matter expertise. And then they switched gears again, and then they went to manufacturing, same idea. They're releasing software to help manufacturing companies, still not a very clear, it requires very clear subject matter expertise, and they didn't have that. And the problem here was they never took the time to define what is the problem that they're looking to solve. They never had a thesis behind what is the business problem that we need to solve. And as a result, they just tried to sell it to everybody. And for the record, AI is not a business problem, or implementing AI or using AI to solve business problems. That's not a business problem by itself. There are a couple of really clear elements that you need in order to have a viable problem to solve to support a business. Otherwise, you're going to end up jumping from problem to problem. You're not going to develop the required subject matter expertise. You're not going to be able to support and build up kind of a client base. So it's a bit of a sad story. A number of people lost their jobs. A vast number of people lost their jobs. The leadership sort of made out okay, but I don't think they're still working for ServiceNow, so they didn't retire with millions of dollars or anything like that. It's a cautionary tale that as an organization, when you're going into solving a business using AI, you want to have a very clear definition on what is the problem that you're looking to solve. So that leads to, well, how do we know if we have a good problem, or how do we know if we have a problem that how do we know if the problem that we're looking to solve is going to be good? And so as a good consultant, I'm going to come to you with a framework because, frameworks. So I like to use this framework. This one works for me. I adapted. It's been adapted from Harvard Business Review. There's been a number of different versions. There's lots of different kind of problem definition frameworks. I'll walk through one with you right now. It's hopefully fairly straightforward, but feel free, if you have other ones, feel free to use them. The important part here is that you're taking the time to understand your problem that you're looking to solve. So the first step in developing your problem is establishing the need for a solution. So 3 key questions here: what's the basic need, what's the desired outcome, and who stands to benefit? If you can't answer these 3 questions, then you don't understand your problem. And Element AI, I hope you can see, really didn't understand these 3 questions. They didn't understand, what was the desired outcome. They jumped from, okay, well, this person sort of needs this, and this other person sort of needs that, but you didn't really take the time to understand what is the specific need and who would benefit from solving that problem. The next step is to justify it. So understanding what are the benefits and how are we going to measure this? And I can't stress this enough. The number of organizations that I see that, we're going to go gung-ho and we're going to release AI-powered washing machines. Well, how are you going to measure how good your washing machines are, what incremental benefit you're adding by adding AI? And is that enough to justify, is that enough to justify building an AI product? And then the second part, and this is again where lots of companies trip up, is how do we ensure a solution is implemented? I think that there's a story that's been told so many times, it's a bit apocryphal at this point, but the Netflix AI prize about 10 years ago now, where Netflix said, we're going to pay $1 million to the team that is able to develop the best recommendation algorithm. And a team developed this wonderful recommendation algorithm with very, very high accuracy and could work, with very small amounts of data. And unfortunately, it took about a minute to run per set of recommendations. And I don't know about you, if I'm browsing Netflix, I don't want to wait a minute for recommendations. I want to know what I want to watch now because, I'm a lazy consumer. So that implementation step, how do we make sure it actually gets implemented? That's important. The third step is to contextualize the problem. So what have we already tried? Often, I've seen, there was an organization that I did some work with before, and the data team, they were looking for trying to understand, you build an AI model to understand web URLs and to parse out web URLs and predict some definitions around web URLs and classify them accordingly. And they brought in this senior engineer and they told him about the problem. They said, we really want to use AI in order to solve this problem. You've got 3 weeks. Can you build us a model? Can you build us something that'll predict, these different classifications for URLs? And he came back by lunchtime and he said, I built a regular expression and it does everything you need. And so like understanding that sometimes you can try different approaches outside of AI and they might suit your need just fine. So understanding what's been tried in the past so you don't repeat it, or that you're not trying to solve a problem that's already been solved. And then internal and external constraints. How does the solution need to run? What's the costs associated with it, and who's actually going to use it? Those are really, really important questions to ask before, in order to make sure you have a good problem. And then the final step in the process is to write the AI problem statement. If you can answer all of the questions before, this becomes a very kind of fill in the blanks exercise. If you can't, or if you're struggling with this part, you may need to go back and revisit earlier parts in the process, and that is okay. It's meant to be an iterative process. You might get through one pass and get to the end and say, I don't know if I can put together this problem statement really, because I don't know if I don't know if my need makes sense, or I don't know if I've properly contextualized the problem. And then you can go back and you can refine that and ask more questions and bring in subject matter experts and build up your case that way. If you go through a few iterations of this, that's when you start to get a really clear problem statement of, what is it you're looking to solve. So walking through an example very quickly, because I never like to give a framework without an example. You always like to be able to see exactly how this is going to apply. The names have been changed to protect the innocent, but this is a real case study from an organization I've worked with in the past. So the need for their solution. They said, we think that our segmentation models that our marketing team is using could be more effective. And if we had better segmentation models, we could target the right message to the right customer at the right time, and thereby we would increase our conversion rate on our advertising. So you can see there, we've got the need, we've got the outcome, and we understand who stands to benefit. Justifying the need, well, we were spending $100 million a year on advertising, and we had an ROI of, I've changed the numbers here, of 100% with a conversion rate of 5% of our ads. So if we were able to increase this conversion rate by 1%, it would result in an additional $20 million of revenue. And then we talked about, how we are going to measure the difference in conversion rate to make sure that the new models are actually performing as expected. Contextualizing the problem, they had tried targeting different demographic and geographic areas by themselves, similar to what their competitors did. And they said, we've got this budget of 250,000, and we've got a team of one data scientist and one marketing expert, and we need 3 months. We've got 3 months with which to solve this problem. So it was a very clear kind of problem definition. It was very clear when and how they were going to go about solving, and there was no questions about what are the resources we're putting behind this problem. And then finally, we were able to put together the AI problem statement based off of all of that information before. Now, if we didn't have that information, we could have gone a completely different route. Maybe we would have spent a year or 2 years developing segmentation models that are very, very complex, but you could never practically target somebody using them because that would be against privacy laws if you're trying to target them down to that specific level or something like that. So it was really important to go through this process with them and understand, what's it going to be used for, how is it going to be used, and that sort of thing. So I'll take a pause there. Questions? Are there any questions? I saw the chat kind of going off. Marketing says it needs to use AI. Yeah, Jeffrey, I know that feeling. All right, we'll keep going then. We'll roll right into the second use case, and then we'll see. We'll keep going from there. So the second use case I'd like to call. Whoops, there we go. Stop isolating your AI experts. So the company I was working for, the story I was telling, the company I was working for, they had a specific centralized data team. They had pitched it as sort of a business intelligence / analytics / data science team, and they did a little bit of everything. They did, as I mentioned, reporting, like more business intelligence type tasks. They did quite a bit of data science, data engineering, and that sort of thing. And they were all kind of grouped into one function. And they sat outside of each of the marketing, operations, finance, and HR teams. So they kind of sat on an island by themselves. This was within one business unit of this very large organization that I was working for. The second business unit did something a little bit differently. They had each of the functions, the marketing, operations, finance, and HR teams, and there were a couple of other teams as well. And they actually had data experts sit within each one of the functions. And I think this was really important because it allowed the data experts to become, deep subject matter experts in their own functional area. And they were actually able to sit with their counterparts who were using their models and understand how they were being used and really deeply understand what problems they were solving. This came to a head and became very painfully obvious when both groups developed churn models for the customers that they were serving. So very, very quickly, a churn model in a recurring revenue business, it's trying to predict who is likely to cancel their service. So if you have ever tried to, cancel your service with Verizon, first of all, I'm sorry. And second of all, you would be churning if you were canceling your services. And what these models try to do is they're trying to predict, which customers are going to churn in order to do something for them in advance of them churning to prevent them from churning. So both teams developed churn models. The first team, the old model team, they developed a churn model and they used recall as their measurement. The reason that they couldn't just use accuracy is because for most large companies, 99% of customers won't churn every month. The churn is usually about 1 to 2%. So if you try and use accuracy as a measurement of how good your model is, if you just predicted no customers were going to churn, well, you would have 99% accuracy right away. So you couldn't really just use accuracy. The team using the old model, they used recall, and so I'm sure lots of folks on this call are aware. I'll do my best to explain it. That it was asking the question: what % of customers who are captured what percent of customers who actually churn are captured as likely to churn by the model or classified as a churn risk by the model. So if you have 1,000 customers, and let's say 100 of them leave, that's a 10% churn rate. And if you predict, if your model says these 500 customers will churn and all 100 who actually churn are within that group of 500, then you have a 100% recall. So that's a very, very brief intro on how recall works. The second team used precision as their measurement of accuracy. So they were saying, of the customers that we classified as likely to churn, that group, how many of them actually churned? So using our numbers again, if you predicted 500 customers were going to churn and 100 of them churned, then you had a precision of 20%. Both measurements are technically correct, but for this problem, one of them is better than the other. And the reason I say that is because for a churn model, if you predict 500 customers are going to churn and 100 of them actually churn, you don't know which 100 are going to churn. You just know that this group of 500 contains the 100 that will churn. And so from a marketing perspective, you have to do something for all 500 customers in order to capture that full benefit. You need to reach out to all 500 of those customers and offer them, some sort of incentive. Maybe it's a discount, or maybe it's a, free feature or something like that, which that's great news if you're on the receiving end of that and you weren't going to leave anyways, and your telecom company calls you up and says, hey, we'd love to give you something for free. But that doesn't happen very often. And the reason that doesn't happen very often is because that's expensive for telecom companies. They understand that if they had done nothing, 400 out of those 500 customers would have stayed. And I use the 400, 500, 100 groupings to illustrate the point, but really churn is closer to 1%. So even if you have a precision of 20%, 20 times what the baseline level of churn is, then that means that 80% of the time you're doing stuff for customers who wouldn't have left anyways. So at the end of the day, both models were implemented, both models were started to be executed by the marketing team. The team that used precision as their metric, they were very, very successful. The bottom line profit went up quite considerably as a result of this, and it was celebrated as a wildly successful program. The old model, they canned the model within 3 months. They said, we're not using this anymore. This model is garbage, and we're not going to use any more AI. So you can see how the fact that the data team was able to actually sit with the marketing team, they were able to understand how their model was going to be executed, affected a design decision of the model. And because they were together in the same business unit, they were able to do that. Whereas the centralized data team, they were sitting, the marketing team basically handed them an assignment and said, build us a churn model. They went away, they built the churn model, and they came back and said, here is your churn model. So the moral of the story here is, when you isolate your AI experts into a dark room and you're just giving them assignments without a whole bunch of context, they're not going to be able to perform as effectively. If they can sit with your team, whether it's from an org chart perspective where they actually sit on the team, which is ideal, or at the very least, get them embedded within the team in some other way, they will be able to produce better models than if they're sitting alone. All right, the final use case here, explaining your work. So I'm going to give a little bit of background. Once upon a time, I built an AI model. It was a model that predicted the probability of call options being expiring in the money at 90 days. And what that means, I'll give you a quick overview of call options very, very quickly, and I promise this isn't tangential, this does matter. So a call option, imagine investors have the right to buy shares at some specific price, buy shares of a company at some specific price on some specified date in the future. This is called a call option. So if you, let's say the price of Apple shares is $20, and today is January 1st, and you say, I want to be able to buy, shares in Apple for $20 on April 1st. What you're doing is you're hoping that regardless of what the market price of Apple shares does, you're going to be able to buy shares at $20. So you're hoping that the price is actually going to go up. So let's say by April 1st, the price goes up from $20 to something above $20, let's say $30. Well, you still have the right to buy them at $20. So you can buy it at $20 and you can sell it at $30. And then you can buy it at $20 and immediately sell it at $30. So you made $10. And let's say that call option, that initial call option costs you $2. So your net profits is $8. So the difference here is the market price versus what's called the strike price. The strike price is where the price that you're purchasing the option at. About a year ago, I developed a multi-layer perceptron neural network model to predict which stocks are going to increase beyond the option price before the option expiry date. Again, it's all about, I want to think about which ones are likely to go up by more than a certain amount. So let's say I give you this information. If I told you today, right now, I think you should buy some share. For the record, this is not financial advice. Please do not go out and purchase shares based off of what I am saying. But if I told you, as an example, to invest in something on the basis of the last slide alone, how likely, and you don't have to tell me, you don't have to hurt my feelings, but how likely would you be to make that purchase? Now, what if I showed you something like this? What if I showed you a bit of a dashboard that said, here are the key factors which are influencing that recommendation? The revenue per share for this company and the free cash flow for this company are both high. And what that means is that they've got high revenue compared to their peers. They've got high free cash flows. They don't have a lot of debt, and they're able to pay a lot of they're able to have money left over after paying all of their debts compared to their peers. The industry has been sort of mediocre, but for the last 90 days, the return has been great. And the only thing holding it back is that the analyst rating, the analysts have said not to buy this company. So here are the factors, the biggest 5 factors that are affecting the probability to buy, the classification on whether you should buy or not. And everything else has a minimal weight. You can see, how highly weighted each one of these are. Everything else has a minimal weight. So think back to, when I showed you the slide before, how likely were you to buy it then? Versus if I gave you this information in addition to the net recommendation of buy this share, do you think this would make you more likely to buy? And my argument is probably, because now you can start to have you can make a more educated decision. You can start to, it's no longer just a machine, a black box spitting out a recommendation to you. You understand some of what's going into it. You understand why it's making the recommendations that it's making. You may not agree with it. You may think, I think that the revenues per share isn't something that should matter for this model, and that's fine. But the fact that you can understand why the AI model is giving you the recommendation that it is, that's what's going to give you trust in the process. And the key theme here is that until our AI overlords overtake us all, humans are going to be in the loop for a long time to come. Humans are going to be part of the decision-making process for a long time to come. At some point, for just about any AI model you make, not every, but I would say for the vast majority of AI models that you develop, there's going to be a human at the end interacting with the model, whether that means that humans are going to be making a purchase of a stock or making a business decision, or making a phone call to a customer that they think there is going to churn. There's an actual human being at the end of the process who's going to be using this. And if that human being understands, they don't need to understand necessarily the mathematics behind the model, because sometimes that can be fairly complex, but at least at a high level, here are the things that are driving this model. And here is why this model is telling me to do this action. Then that makes them much more likely to trust the process. And it also makes them much better users of that process. One company that does this especially well is Salesforce. So Salesforce has a product that's called Einstein AI. It's not, I would say, true AI. It's more of a logistic regression with some fancy bells and whistles. But what it does is it takes the coefficients for the logistic regression and it translates that into something that's human readable. So it'll say, hey, I'm making this Einstein AI is making this recommendation based off of the fact that these three factors are very, very high. And the idea behind the reason that they do that is because Salesforce is meant to be used, as the name implies, by salespeople. And so when a salesperson can look at that recommendation and the recommendation says, hey, you should talk to this customer because we think they're ready to buy. A salesperson, and I don't know how many folks on the call have worked with salespeople before, the natural inclination is going to be, well, I've worked in sales for 20 years and I don't need no damn computer to tell me what to do. I know how to do sales better than anybody. That's my best salesperson impression, by the way. I apologize if I've offended any salespeople on the call. But if you can tell that salesperson, hey, we think you should talk to this customer because they have looked at the ad, they've clicked on an ad 3 times in the last week. They spent 20 minutes on the website reading this article about our products, and they submitted a contact me form that says that they want to learn more. So these 3 actions together, we think represent somebody who's ready to buy. If you give that salesperson that information, they're much more likely to act on it, and they can even use that information as part of their sales pitch. They know exactly which product that customer has been looking at, and they can use that and they can tailor their sales pitch to that. So they can use that information as well. All of this to say, humans are going to be in the loop for a long time to come. So when you're designing AI systems, make sure that you are giving that extra level of information to the humans so that they can use it appropriately. We've reached the end. So if you remember nothing else from my presentation other than the power outage, please remember these 3 things. So number 1, you got to define your problem. Understanding the problem is the first step of your process before you start writing code or building models. Number 2 is embedded teams. Make sure you're not putting your AI experts on an island somewhere. They need to live with your teams to understand the business problem. And number 3, explain your work. If you can provide technical and non-technical team members a way to understand the model's output and why it's coming with the output that it is, then it helps people trust the model a lot more. So those are the 3 kind of takeaways. If you can remember nothing else, please remember those things. With that said, thank you so much. I am Fraser Gray-Smith. It's been a pleasure chatting with you today. I know I breezed through that whole thing with a minor hiccup in the end, so I'll take a pause there and ask if anybody has any questions.
Feel free to come off of mute, or you can drop your questions in the chat. I know oftentimes people are not in locations where they can come off mute, but they still want to participate in the Q&A. While we're waiting for everyone to gather their thoughts, Fraser, what is the AI use case actually in the world that you're most excited about, that you were very jealous to see that somebody got to work on it?
Oh boy. Okay, so this is a fun one for me in particular, and I'll tell a little story about it. So the there is an AI assisted. There's a number of AI assisted code writing programs out there. What it does is it helps developers. You kind of give the AI some prompts, and it helps developers understand, or it helps basically write code on behalf of developers. So you say like, hey, I want a website with a blue button or something like that, and it'll actually build the HTML code in order to do that, which I think is something that's really, really cool. And the reason that I think that it's so cool is because as I mentioned off the bat, I'm still doing my master's in computer science, and for that master's, I've had to learn how to program in C. Now my C is hot garbage, and I know it's hot garbage. But if I had known this like at the start of my program, I would have used this in order to help me get past all of the syntax around pointers. And if anybody on the call has ever had to work in C, you know what I'm talking about. You know, having to deal with specific memory locations and malloc and realloc and all of those fun commands. I would have appreciated that. So the product is called GitHub Copilot. It's developed by Microsoft. Microsoft bought a company called GitHub a number of years ago, and they basically use it's got billions of lines of code, and it uses all of those that developer knowledge in order to help you build stuff. I'm really excited about that personally, because it helps to speed up the development process so much when you don't have to, you run into something and you go, oh, I don't remember the syntax on how to do this. And you spend 10 minutes Googling around, going to Stack Overflow, trying to find out what was the specific syntax for that thing. You can just tell GitHub Copilot, build me an HTML page with a blue button, and it fills in all the rest for you. So I think that was really, really cool.
Amazing. I love how excited you're about that. Alex dropped a question in the chat, which is, how do you explain to non-tech people what AI is?
Ooh, I like this one. So the explanation that I give to my parents on what I do every day is that AI is just math applied to decision-making at scale. So there's kind of three parts of that. So the mathematics is fairly straightforward. The mathematics isn't straightforward, but the idea of math is straightforward. Applied to decision making, because really that's what AI is about. It's about making decisions. And then the scale part. And the scale part is something that explains why AI has become so huge over the last 10 to 15 years. We have more raw compute power than we have ever had in the history of humanity. And it's available at your fingertips. I can, in about 10 minutes, I can spin up a giant AWS server or a Google server somewhere in the world, and I can have, as much compute power as I could possibly want, so long as I'm willing to pay for it. That wasn't available even 10 to 15 years ago. But because we have that power at our fingertips, we can do that. It allows us to apply that mathematics at a much larger scale, much faster, using a lot more data than we ever could before. So that's how I personally define AI.
I love that. And yeah, how do you explain what you do to your parents? That's a great conversation topic, just in general.
More to the point, explain to my father and mother-in-law, what is it that you do every day? Yes.
Yep. Yeah. Any more questions?
In essence, so I see one from Sergey. C programming is a business model. Yeah, it has been, yes. Can AI be used in programming? Yeah, I think so. So, the GitHub Copilot example that I gave off the bat, if everyone wants to try it out, it's free for 3 months. You got to sign up. If you're a developer, I can't recommend enough taking a few minutes to try it out. can it be used in programming aside from that? I think the answer is absolutely yes. So if you think of, the full DevOps life cycle, right? You think of, you want to, you could use it as part of the actual development. So you could use it, functionally writing code. You could use it in order to deploy code. So when you hit deploy, you could use AI to, I've seen AI use cases where they're actually testing the code before it gets deployed in order to check for things like security vulnerabilities, in order to check for things like user experience, in order to check for all sorts of different things. Now you can do that, in a much more mechanical way, but by applying AI to that process and that development process and that to that deployment process, really, it allows you to check for so much more, and it because it's a sort of a self-learning process. It learns which mistakes to look for. So that's another really interesting use case that's applied to programming that I've seen. Sergey, does that sort of answer your question?
Oh, you just clearly present the point of view from your point on my subject. I'm a professional programmer for 50 years.
Okay, good. Yeah.
So when you say something right now, and very enthusiastically, you can do this, and I'm as a programmer think, wow, interesting. Why I never heard this before, and I never saw any examples of this in reality. So if it's so easy to turn AI and use it for programmers, because the programming is exactly as a business.
Yes.
You have resources, you have command, control, you create this, you do this, you run it. So why not using the AI there? And I never heard about any practical implementation. That's amazing.
I think I don't want to provide too many of my own forecasts, but maybe I think over the next 5 to 10 years, I think you're going to see a proliferation of AI within programming tools. And the reason I say that is, so Microsoft got into the game and they released GitHub Copilot.
Yeah, I'm using GitHub daily.
Yeah. So GitHub Copilot, it's literally just you click to activate, and then you can start using it within VS Code or whatever your preferred IDE is. Amazon has purchased a number of companies over the last year, in the hundreds of millions of dollars of purchases around DevOps, AI for DevOps, and making sure that you can have a smooth development pipeline and using AI to smooth out some of the edges of that development pipeline. So Microsoft's in the game, Amazon is in the game. If I had to guess, Google is probably doing something. I haven't known them to fall too far behind. So once those three get in the game, you're going to start to see that integrated.
Still, you see, what's very interesting. I am in AI for many, many years.
Yeah.
And what you're saying, it's very enthusiastically, but I see as a professional PhD, whatever AI guy, and I'm trying to think how I can use available right now technology in AI in a simple software development.
Yeah.
And I don't understand how yet.
I'll maybe
just say me that Amazon there. I'm an Amazon developer. I'm an AWS developer. But still, when I'm writing a code and doing simple thing, everything what you mentioned in AI is some kind of statistical model and approaching, this optimization way.
Yeah.
Doesn't work. Interesting.
The other, so I saw Jeffrey popped the link to GitHub Copilot in the chat. It's fantastic. So plus one for Jeffrey for dropping the link in the chat, and then -1 for saying Vim forever. I don't want to start an IDE war here, though.
All right.
The other kind of interesting use case I've seen for AI is this is maybe more on the consulting side, but one of the things I've seen is using AI for topic summarization. So given a text, an AI, and you can use an AI algorithm to read a giant text document and then summarize that giant text document into a few lines. And the way that I've started to see it being applied is, for example, Microsoft Teams or even Zoom has automatic captioning capabilities. So imagine an AI bot listening to your entire conversation, the entire meeting that you've had, and then transcribing that to text, and then creating a quick summary of that entire meeting. So now you don't have to do, it'll be, a few years, and you won't have to do meeting minutes anymore. You won't have to send out meeting minutes, or you won't have to, if you want to remember, oh, what was that meeting about last week? What did we discuss then? And you can't, maybe you didn't take a recording. Well, it'll provide you, a 1-paragraph summary of here's all the things we talked about. And I like that personally because I send out a lot of meeting minutes after meetings, or I spend a lot of time, recapping, hey, here's what we talked about in the meeting. I would love an AI bot to do that for me. And that's one of the kind of edge use cases in the workplace anyways that I've seen that I'm excited about.
I think every project manager ever would really appreciate that. This is a great discussion. Anything else? Don't be shy. We have time. Oh, that's an intriguing article title. Is GitHub Copilot a blessing or a curse?
Full disclosure, I have read that article. I did read it when I was messing around with GitHub Copilot, and I think it's an interesting point that right now AI learns from other examples, of course, right? Like it takes other people's GitHub Copilot specifically, it takes other people's code, and then it makes slight changes to it, and then gives it to you in your format. So it'll give you so a sample of code. And I think that's great if you're not as familiar with the syntax like I am in C. I wouldn't have to memorize so much C syntax. I would only have to I'd have to learn some prompts, and then I could focus much more on what's the structure of the program, and how do I theoretically want to solve this problem, and I don't have to worry about syntax so much. However, if it's pulling from examples that are bad, then the code it will give me will also be bad because it's learning from bad code. And by nature, and I say this as somebody who's worked as a developer, sometimes developers write bad code. And because we're lazy or busy, or because we don't have enough time to implement a feature properly, or because it's not, essential to the project, we'll do things the kind of lazy hack way. But if an AI is learning from that, then they're going to give you hack ways of doing things. So it's an interesting dichotomy, right?
It's the same challenge with bias in data and technology. And so if you're training your model on a biased or incomplete data set, then it is going to learn how to continue to be biased and incomplete.
Garbage in, garbage out.
Exactly. First thing you learn in any data career. Anybody else? This has been fantastic. Thank you so much for joining us. Thank you everyone for coming and spending some time with us this evening. If you would like to hear more from Fraser, he recorded a podcast with Justin, who unfortunately couldn't be with us this evening, but they recorded it last month, and it is set to go live on November 15th. And yes. Also, Fraser and I are collaborating on a Medium article on marketing use cases for AI. So we will be sure to post that in all the places once we get through our drafting phase. And please connect with the Applied AI community on our Slack channel. And one more reminder, the link is in the chat. Our first in-person Applied AI conference is coming up in November. Early bird pricing ends tomorrow, so please sign up tonight.
Thank you, everybody, for listening to me ramble today. I really do appreciate it. And thank you, Allison, for having me.
Thank you so much.